Thanks, Judy, and I'm going to embarrass Kristen by asking her to stand up, and Matt. And I also, and this is Michael of course, but I also want to acknowledge that one of the other people who's a really important part of the team, Bruce Farrington, is back in Canberra. I hope he's gone to work today, but I'm not there to keep an eye on him, so I'm not sure whether he's there or whether he's enjoying a coffee with someone. It's also a really exciting day today. Not only is it April Fool's Day, but it's the very first day on which our amazing administrative coordinator, Amy, starts full-time work for us. Fortunately, she started part-time work about 5 or 6 weeks ago, which is very fortunate because we wouldn't have got here unless she'd actually got us organised to have a car and be able to come up from Canberra. But I don't know if Amy will ever get to watch the video of this that Eddie's making, but if she does, Amy, we really appreciate you. So I just want to set the scene a little bit for the project in a minute, but first of all, I think I'm going to hand straight over to Michael, who's going to give you a little bit of maths to do after our time.
Just to put me in context, I'm secondary trained, and in the ACT I've worked in 4 different schools, all of which I had some lead teacher responsibilities in, and prior to that I worked with Questacon and CSRO going into, I think, just over 1,000 schools throughout Australia, having lots of fun working with young people. So for me this is an interesting project to be involved with because I don't have that direct contact with kids all the time, and it's, you know, a little bit sad at times, but I've got my own little lab at home that I experiment with, and I'll share some of that with you a bit later on. But as Steve said, this is our team that's here today, and the activity that we're going to have a bit of a start with is up here on the screen. It's lots of colourful shapes, and I'm going to give you guys a couple of minutes just to have a bit of a look at that, have a little think about it, and a bit of a chat with those around you about what you think's going on here, what you think you might be able to do with this, and then we'll have a little discussion together. So, 2 minutes? Great. That was fantastic for me to see. I haven't presented this to an audience like this before, and straight away people launched into it, which was brilliant, but also seeing what was happening with your hands. It would be, oh, if you guys could have seen that, the smile that brings your face was amazing. The lines that were going up and down, side to side, but rather than me going through what I've got out of it, can I have some ideas from you guys? What were some things that you talked about? There's no right. Yeah.
Thought maybe it would be useful for maybe like end of year 7 or beginning of year 8 if kids haven't really got the idea of an unknown just yet, because using the puzzle, I had a bit of a play around on the internet yesterday, and I thought maybe it'd be useful to present, like, before using letters, using those shapes might sort of give kids a bit of a segue into it.
Right, so some introductory algebra type stuff. Yeah, does anybody have a go at trying to work out what was going on? Who wants to share some strategies they used?
There we go.
Oh, sit behind the light, yeah.
So, for solving it, you mean?
Yeah.
Well, I noticed that both sides have 2 greens, so I got rid of those 2 greens, and then I had 3 greens is 2 purples, and so I said 3 greens is 12, so 2 purples must be 12, therefore it must be 6.
Okay, so we've got a strategy and a possible solution. Any other ideas apart from the getting rid of some of those greens going across? Did anyone write down a formal equation? Anyone use an algorithm?
Probably did in their head.
Did it in your heads? Just eliminated some colourful shapes? Yeah. Oh. Yeah, the answer's 6. Correct. Another little mobile going on here. A little bit different in how it's set up. But again, I'll just give you a minute this time to have a bit of a play, chat with those around you. So I didn't give you as long this time to have a bit of a play, but once again, what I saw was hands going across and up and down, and there was also a bit of this happening right at the back there, and a few people were getting their bodies into it as well, which was, yeah, great to see that enthusiasm. Quick chat, some strategies, some ideas. Where did this particular image take you?
They talk a lot in class.
I want to know what the 14 is.
Yeah, I will address that.
One question.
Yep.
You're talking about a fulcrum there, and so presumably that's at the midpoint in order to be able to work it out. Is that correct?
Yeah, absolutely. So I didn't give you guys any context about this, just showed the picture, and later on I'll show you some things that I've had to play with my little lab at home. But yeah, it's the balance scales. There is that assumption, it is that pivot point, and that's something that, yeah, we did notice. I'm glad to notice that my kids at home did sort of go, is that like a seesaw thing? But the number in this case is all of these things dangling off this seesaw, like the balance scales, they all add up to that total amount, that total 14. And that's something that when we've had a bit of a play in class, some kids just assume that's the case, and others do need that clarification. They want to just check and go, so is that like a target number? What's going on there? But yeah. Does anybody feel like they've got a solution? Would you like to know? Again, did anybody... Yep.
Can I just make a comment? Initially, I didn't actually notice the 14, and I thought that was really interesting that you could have equations with unknowns and variables. And I was saying to Jackie, oh, the pink ball could be anything. And then by putting the 14 in that she noticed, it was like, well, there's your simultaneous equation. So it was like an interesting discussion.
Yeah, there's that little bit different to this one here, where we didn't need to have that target number and a bit of substitution, but yeah, we can set up those equations, absolutely. So that extra layer of complexity and what you can do and where you can take it.
I think what's lovely about these is I reckon you can do them with a grade 5 or even grade 4 class.
Thank you for that comment as well. And that's something, and that's something I'll definitely pick up on and share some stories with you as well about that. So that's some nice fun stuff to get started, and now Steve gets to do...
I get to do the boring bit. I do want to say, though, that that particular problem is not something that we as a team developed. I really wish we had. But we got sent the link, I think, through Matt, who originally got it perhaps from Charles Lovett. I'm not quite sure how it got to us.
No, I can tell you. My single source of good ideas and maths is from Twitter. And this just came in on my Twitter feed.
Okay, thank you. So it was Matt's Twitter feed, and Judy's twittering now, are you? Is there a Twitter feed for this?
Yes.
Great. But I should add that we have some amazing people who are also working on the project who are not actually part of the full-time project team, including Charles Lovett as a consultant, and those of you who've ever looked at Maths 300 or the predecessor of that, which was MCTP, will know of Charles's work. But also Kay Stacey and Peter Sullivan from Melbourne, and Kay and Peter would be the two most respected maths education researchers in Australia, possibly. Peter had a major role in the Australian curriculum, and also getting, we have an agreement with the University of Nottingham, who, through people like Malcolm Swan, Hugh Burkhardt, and if you've ever looked at the maths assessment website, from the Shell Centre at the University of Nottingham, then they're also helping. So we have an amazing team of people, not only those who are working, the amazing people that we've employed working full-time in Canberra, but also a big network of consultants. The other big network of people that we have are the 200 odd people, 130 people in this room, and the other 20,000 or so people out in schools. One of the things I'm really looking forward to today is all of those Teach Meet presentations, because we're going to grab some of those ideas that people have, and we're not going to steal them, of course. We are going to talk to you and say, would you like to incorporate this into a mathematics by inquiry package? And then we can perhaps consult with you and develop some really interesting and worthwhile activities. As Judy said, this is an Australian government funded project. This was the brief from the Commonwealth. It's not quite what it's evolved into now, but that will do. It's very much part of the whole STEM agenda. Judy mentioned Professor Nalini Joshi from the University of Sydney. Nalini was very influential in talking to the Chief Scientist, or the then Chief Scientist, Professor Ian Chubb, who also had the ear, of course, of governments. And so a couple of years ago, the then Prime Minister announced $12.5 million for STEM education, which included some coding across the curriculum, but it included $7.4 million for mathematics by inquiry. So that's where this has come from. The Australian Academy of Science, in collaboration with the Australian Association of Mathematics Teachers, put in a tender for the project, and that's how I had the privilege of moving over to Canberra. project runs from the 1st of November 2015 till the middle of 2018, formally, although what we're hoping is that in June 2018, if there's more funding, that's great. If there's no more funding, then what we will have is a legacy of classroom resources, professional teaching, professional learning resources, and also a whole lot of teachers who are enthused by mathematics by inquiry and have become what we're calling, what the Commonwealth has called champions. So we're looking for people to become champions who will take the project beyond its formal life in June 2018. This is what we've been contracted to do by the Commonwealth, and you'll see these gradually rolled out. All I can show you today, because it's all we've got so far, is the very first dot point, which is a protocol, if you like, a framework. This is our vision and rationale for teaching in mathematics by inquiry, or Resolve as the project's coming to be called. I can show you that, and I want to reflect on the protocol in the light of that little activity and talk about how it illustrates or highlights bits of it, or perhaps doesn't. That's surrounded by a package of professional learning resources. Each of those will highlight an aspect of the protocol which informs teacher and whole school change. So over the coming couple of years, and hopefully beyond, many of you will be engaged in activities at a school level, at a regional level, even at an individual level, interrogating mathematics by inquiry, interrogating the protocol, looking at classroom resources, looking at professional resources. Those professional resources form the basis of that professional learning, all of which will be linked to, what's it called, TQI? AQI? No, it's not school, the professional learning standards. What's?
Yeah.
Sorry?
It's TQI in the ACT.
TQI, TQI in the ACT. Whatever it's called here. Yes, the teaching standards. So you'll be able to count this as part of your professional learning. That's very much part of our thinking. Highlighting and, I guess, exemplifying those professional resources will be some classroom learning experiences. They might be whole lessons, they might be little snippets, they might be little activities like you've just seen at every level from foundation through to year 10. That's the brief of the project. There's no brief to do anything prior to school, there's no brief to do anything in year 11 and 12, but certainly foundation to year 10 there will be at least 8 exemplary classroom resources or lessons at each year level. In addition to that, there'll be what we've called special topics, which will be more substantial units of work, or purposeful technological developments, apps, whatever they are, which will actually make a difference and improve teaching, as opposed to the headline from the Sydney Morning Herald or whatever it was that said technology is getting in the way, or something like that. I haven't read the article. We don't intend any technology that we use to be an impediment to students' learning. We certainly intend to do exactly the opposite. All of which will be disseminated through Scootle, so all of the classroom resources will be freely available and through a Creative Commons licence, and the Australian Association of Mathematics Teachers Dimensions portal with the 240 champions. Oh, back to Michael.
So we get to have another chance to investigate a little bit further and something a little bit more complicated. These are still hopefully relatively accessible for everybody in the room, regardless of background, but you're here for a reason. So have a couple of minutes. Pick one of these things to look at. Do both if you want. 2 minutes, and then we'll chat. Lots of productive conversations again, which was fantastic to see. How many people had a go at the puzzle on the left? How many people had a go at this puzzle here, number 38? Couple, okay. How many people had a go at puzzle number 50? And how many people must have done both because you didn't raise your hand for either?
Or no. Chat about something else.
Just have a chat. Again, it was really good to see those hands going all over the place, looking at our columns, looking at our rows, cancelling out. A few people started to write some things down this time, so incorporating a different type of strategy, probably more of that traditional approach to the one that we've experienced when we've grown up with our maths education and whatnot. But for those that did Puzzle 38, what sort of strategies did you use? Was it the same as those earlier ones? Was there something different? Love to hear what you did. I know people did it. You raised your hand before.
Well, this is kind of like one step further from when they just give you the number at the top. Yeah. But that's kind of equivalent to what it's doing, because they've given you that blue thing over there, which means the other side must also balance to 6.
Yes.
So they might as well have said that whole chandelier on the left is 6, but this is just an extra step out.
Yeah. Cool. Yeah, so first of all, looking at the fact that there's that big overarching balance part to begin with, so we know all that stuff in that left-hand side has to add up to 6 somehow. Right? Yeah. Other strategies? Or does anybody else identify something a little bit different to start with?
You have to start from the top. You couldn't start from the bottom. I tried initially to start at the bottom. It didn't make any sense. You have to start at the top.
Yep, so starting to look at the pink squares and the green circle, going, there's a balance aspect there, but it could be anything. There's lots of solutions there. We need that other information. Yeah, great. Puzzle 50.
Awesome.
What makes it so awesome?
It's just fun and colourful.
Yeah.
No, because kids will want to solve that, right? Like, I wanted to solve that straight away, and it's cool because if that was presented as equations, there's only a certain level of maths that would be able to access it, whereas a kid could get that question out.
Yeah, so your experience as a teacher and lead teacher as well, you're one of the lead teachers, so identifying from your experience, kids you interacted with, they'll just want to play with that, they want to do it.
Absolutely.
Yeah,
even kids who don't like algebra.
And there was a hand up, maybe. Yeah.
Oh, just the strategy of how to do it.
Yeah.
Oh, I look at the right-hand arm and take away 2 oranges, so you know a green equals a blue and an orange. And then the moment you've got an equivalence for those, then you go to the left-hand column, and you can then eliminate, and you know that they all add up to 14.
Right, so that's sort of incorporating the starting at the bottom strategy rather than looking at the top number. So in this situation, that was a lot more helpful. There was a hand that started to go up there. Yeah, great.
You just go a little bit further, so it always cuts in half each time, so it's 14 and then 7, and then just...
Yeah, so that's that top-down approach, looking at the balancing either side. Yeah, absolutely. Yeah, great. And using the numbers early on. So different approaches for the same problem, and that's certainly one of the things I like. If you want to know the exact solutions, you've either got to be comfortable and confident with your own abilities, or you can go check out the website, because I'm not putting them up there for you. The next thing I want to share with you is actually something that one of my kids has done. And it's from the website. So as I mentioned before, I'm very fortunate in that I've got my own little experimental lab at home, and yeah, I've got 6 kids, it's kind of busy. But this one here is something that my oldest, my stepdaughter, had to play with just the other day. Okay, so that's the website, and hopefully some people have gone in and had a bit of a look already. I've already logged in. And this is the one that she created. Just before I go back onto that though, the context of it was Wednesday night. I probably should have done it earlier. But on Wednesday night, 7:30 at night, I said, Kaya, she's 11 years old, grade 6, B grade student for mathematics, A grade for everything else, actively tells me that I'm boring and she doesn't like maths. And I said, look, I really need your help. I've already put your name on this presentation. I know it's 7:30 at night and you'd rather be reading and painting, but can you please just have a look at this thing for me, 5, maybe 10 minutes, create something so I don't get in trouble with my boss because I've already said, don't worry Steve, yep, I'll definitely do this, she'll love it. And she went, oh, okay, I suppose. We got in there, I showed her the same puzzles that I showed you guys, had a bit of a play, said this is what it is, didn't actually tell her how it worked, just went, this is the presentation. She clicked on some stuff and she goes, oh, can I make my own? And I went, great, that's exactly what I want you to do. So she made her own. And that's what she's made. That's what she decided to make. So given that my 11-year-old stepdaughter who doesn't like maths made that, and it only took her 2 minutes to make it, no pressure, but a bit of a play. What do you guys come up with? I don't know. Got used to it. Absolutely, and that's actually what Kaya did as well. Those first couple, she was moving her hands all over the place, doing that, twisting her body. But then when it came to making her own, she just knew what to do. And I was actually a little bit surprised, to be completely honest, that she found it so easy so quickly. All that being said, while she was making this one, my 8.5-year-old stepson and my 8-year-old, as of yesterday, 8-year-old son, both came over and just went, "Can I have a turn? When is she finished? I want to do it. Can I make one?" I said, "No, guys, look, sorry, it's 8 o'clock, you should be in bed. If you can go to bed right now, I'll make sure I leave the website behind and you can have a play tomorrow when I'm in Sydney." So, strategies, ideas. What'd you do with it? Because all 3 of those kids came up with a different way to come up with the answer, or how they solved it. So, yeah.
So the right side is equal to the left side, so you can split them down the middle and say, okay, the right side is equal to 21, and then you're given the 9 for the crescent, and that means that so the orange must be 12.
Alright, we'll go with that. Okay. Other ideas, or somebody want to extend with what we currently have, assuming, or if you're happy to take the fact that that's 12, I'm going to trust that. I wasn't sure this first. You guys light it up? Yeah.
To make it a bit more complicated, you can move the fulcrum to a ratio.
Did you
Yeah, you really make it.
Yeah, so they're coming up on the is it a balance point and what sort of thing. Absolutely, absolutely. So there's lots of ideas. This is sort of that launching pad, that platform for where could it go, what if you did this. And that's something that I do like as well. But in this case, it is balanced. We've got a nice even seesaw, nice even balance scale. So what would our purple teardrop? Oh.
I'm very tiny, can't see me. But I was just wondering, is there a possibility of making this for the younger ones, right? For them to sort of play around a bit, as in like, you've got the puzzle there, but they can actually move it and see what happens if they put that in here or something, just to see how it moves. Maybe, I don't know, can you do that? Like, okay.
No. Thank you so much. That's exactly what I wanted to show next. That was brilliant. Thank you. And being secondary trained, and I feel like I'm relatively good with this sort of stuff. When Steve's not watching and when Kristen's busy working, I quite often jump on here and just have a play myself anyway. I hadn't noticed that feature at all.
Oh.
At all. That got pointed out to me by my 11-year-old. Because after she was doing the other one, she looked up this list of these awards and she goes, "Oh, you haven't made an equation and you haven't got that award. I want to get that award. How do we do that?" Yeah. So she went on there and she just started writing things, drew a picture of a unicorn, tried to write the word equation, didn't get the award, and then went, "Oh, why don't I just drag this over?" And I go, "What are you talking about?" And she just did that. And I said, "Why did you?" And she just made sense. So, okay, cool.
Show us what happens when you get it wrong.
Well, what's a wrong answer?
5.
Oh yeah!
And that was also something she said, "I want to get something wrong." And so she went, but then it just caps it at the 999, but you still get that balance. So
then when you get it right.
And a lovely little conversation occurred as to why 0 was equal to 0. But, so what is it here? Seems to balance. Oh, right. Okay. So, making your own, bit of fun, and lots of different things come out of it, and those conversations that we had were great as well. As I've spent too much time sharing how much fun I had with it, I'll very quickly show you guys how you can make your own And if you get the opportunity throughout today, you can have a bit of a play and make your own, and I'm of the understanding that Matt may search for some of the ones that you've created. So these ones I've created, and they can all be found in here. So,
Oh, wow.
so these are the ones that I've made. Well, I've made and Kaya's made, but it's in my login, so it's mine. Through the main menu, either play or build. You can choose. But so it's as quick and easy as clicking, dragging, choosing which ones you would like to show, having this extra shape in that you've then decided not to use. You can just get rid of it. You can add in extra balances, all those sorts of things. And once you save it, it then becomes part of your saved puzzles. If you want to then share it with the community, you actually then have to go back and solve it, just to sort of remind the system that, yeah, it was real. And one of the great things that I found when making the first one was that there's not always one solution, and it will accept those. It will accept alternative solutions, not just that one that was identified by the original creator. So that's a bit of fun as well. After she did that, back in the playing section, she got bored with these other ones. Like, I want to do decimals, I want to do fractions. So had to go over a couple of those that do involve some fractions, and then went, oh, I want negative numbers. And so these are actually all the ones that she did. They're all the ones that she did. This one here looks pretty full on. But when you set it up using the equations, and when you have that formal process, it actually comes out really nicely, really quickly. And something like that, she solved this one in about 10 seconds. Because I looked at that and I was trying to manipulate things, and she just went, oh, the answer is this and this. And it was just absolutely amazing. Absolutely amazing. So, as I mentioned, I spent too long sharing my great experiences with it. So if you do get a chance, please have a play. If you've already created that login, it'll make it a bit quicker and easier to do that. And we'll try to find some of those and pick up on that later. And from there, back to Steve, who will sort of make those connections with the protocol and some of the things we've just been doing.
Okay, thanks, Michael. We think the protocol is we hope that that's what's going to make this project a little bit different. There are plenty of mathematics resources around. There are hundreds of them, a lot of which sit on teachers' shelves and gather dust, no matter how good they are. We want to try to capture what it is that makes those things really good, and try to make what we've called the protocol part of the language of every teacher in every school in Australia, by saying this is what we really value in mathematics teaching and learning. That's why it amplifies rather than replaces existing approaches to teaching mathematics. We're not trying to say, throw away everything you've ever done. We're not trying to say, never use a textbook or anything like that. We're trying to say, why does this stuff make a difference to students' learning, rather than trying to revolutionise everything. So that's why we're saying we're trying to amplify and highlighting those key aspects that are related to three things, which I'll talk about now. The first one, the first dimension of what we call the protocol, is that resolved mathematics is purposeful. And let me say that this is not publicly available yet. It won't be publicly available for about 2 weeks. But then it will be on the AMT website, it will be on the Academy website, and people will be able to access it, print it off, and hopefully use it as a conversation starter. I'm not going to read it through, but I want to focus on the second dot point, in particular in relation to the mobiles, the Solve Me activity. I think that particular activity does two things brilliantly well. The first is it focuses on a substantial mathematical idea. Part of that's algebra, but I think there's something much deeper and more substantial in those mobiles, and that is the idea of equivalence, because that's actually what they're about. There is a heap of mathematics education research that says when you write an equal sign, students say, oh, I have to do something. It's an instruction to calculate. So if you put up something like 7 plus 5 equals 6 plus something, they will immediately add the 7 and the 5. Instead of saying, oh, 6 is 1 less than 7, so I need 1 more on the other side to keep it balanced. The idea of equivalence is absolutely fundamental to our understanding of algebra. The idea of an equal sign as a relationship rather than an instruction. And I think the mobiles activity does that beautifully. The other thing I want to argue that it does is it gives students power. Whether it gives them power in their lives, I mean, in a sense, it's not a real world kind of activity. But Michael's stories about Kaya and the power that she had by being able to make them find her own ways of doing it, I think were quite astonishing. And the fact that she was prepared to spend an hour just playing, and the 8-year-olds came and said, when's it my turn? I want to argue that a lot of the power in mathematics classrooms typically resides in the textbook. And I'm not having a shot at textbooks, but I think students particularly become slaves to the textbook. You have to do these questions because that's what comes up in this order, and the only way I'm going to find out if I'm right is if I check the answer in the back of the book. And again, I'm not saying there's anything wrong with that, because I think there's a really important role for really well-constructed problems to solve, practice exercises in textbooks. They're all important. But I don't think they give students a lot of power. I think this does it in a way that no kind of written resource like a textbook really does. I'd argue that it does a lot of those other things there as well, but I'm not going to talk about those now. So that's the first dimension of the protocol. We want every mathematics lesson that's part of this Resolve Mathematics by Inquiry project to have a very, very clearly articulated and strong mathematical purpose, so that that's transparent to teachers, it's transparent to students. It's not always easy to see what the purpose is, and it might have something to do with the curriculum, but there's something much deeper about purpose that we want people to think about. This is the second dimension of the protocol, that the Resolve lessons are challenging yet accessible. I want to highlight the second point, and again I could have highlighted, I'm sure, all of the others. But again, Michael's conversation with Kaya, there was sustained inquiry. How does this work? The question about what does the number at the top mean? And I think it's great that we didn't actually know what it meant, because that's part of the inquiry. What's going on here? Problem solving, decision making, how we're going to solve it, and we saw the communication in the room. We want all of the lessons to engage that sort of inquiry, problem solving, decision making, communication. That doesn't mean that every lesson is going to be or every activity is going to be a 3-lesson, 5-lesson, 2-week inquiry into climate change and how mathematics relates to climate change. That might be a really important and useful thing to do, and it's a great STEM project or whatever. We also want to interpret inquiry with a lowercase I, not an uppercase I, which means that what we want to do in every lesson is have students saying, well, I wonder if, or what about that, or if I did this. And it might not be some great lengthy project-based thing. It might just be, I wonder if. And if in every maths lesson, in every class in Australia, we could have students saying, well, I wonder if, wouldn't that revolutionise maths teaching in Australia if only we could say that, instead of, I don't understand. Huh? I don't get it. Tell me how to do it. If they said for themselves, I wonder if, what sort of questions can I ask to help? That would make such a difference. So that's the second dimension. Purposeful, challenge and access. Here's the third one. Resolve classrooms have a supportive knowledge building culture. I want to highlight particularly the knowledge building bit. There is a lot of research in education which says that classrooms in Australia, all over Australia, are really supportive. The teachers are lovely. The students actually generally kind of like being there. Teachers get on well with students generally. There's plenty of evidence that says that, and no one learns anything, or no one learns very much. The research that was done in Queensland with the New Basics project years ago, which was also part of the New South Wales model of quality teaching, had one of the dimensions, I think, was intellectual quality, and that was the lowest dimension. That's why I want to highlight knowledge building as critically important. I want to highlight the fourth dot point here, which kind of looks a little bit odd in the context of that lesson. We think one of the really important dimensions of mathematics is fluency. We want to highlight fluency in a little bit of a different way to the way in which we might traditionally think of fluency. I think it was a problem-solving lesson, sure, but I think it also does fluency in a really powerful kind of a way, because it gets you looking at the relationships, and after a while you just become quick at identifying, oh, this and this, or this number has to be even because there's two of those that balance one of those, so that one there that makes two of them, that's got to be even, and it's got to be half of that, so you had the halves and all those kind of relationships there. One of the things that we want to do is to try to develop and articulate some really powerful, worthwhile, important fluency activities. One of our colleagues at the University of Nottingham, Colin Foster, he uses the term mathematical etudes. Now, I don't know if have we got any musicians? An etude is a mini piece that helps you to practice for concert performances and whatever. But the etude in itself is not just playing scales, it's actually a little mini piece that's worth playing all of its own. It's actually got something really kind of nice about it that's worth doing. But it leads into something bigger. That's how we want to perceive fluency, that we want to create little activities that are just worth doing because they're kind of nice and there's an inherent value in doing them, but they point the way to something bigger. And I think this does that really nicely because it's just a little activity that's worth doing, but it points the way to something bigger, which is algebra as a way of modelling the world and relationships. So that's our protocol. Mathematics that's purposeful, challenge and access, supportive knowledge building culture. We're going to publish that, we're going to elaborate on the different bits. But my real hope, I'll just go back to that for a sec before we do the context. My real hope is that in June 2018, or before that, but certainly after June 2018, those three phrases, purposeful mathematics, challenge and access, supportive knowledge building culture, become part of the fabric of the way we think about teaching mathematics and students learning mathematics in schools across Australia. That's my contact. That's Matt's contact. The reason we put those up is that we serve two very different purposes. The bit that I haven't talked about, because I don't want to, and Matt might say a little bit about this afternoon. My role is as Executive Director of the project, so I sort of have overall responsibility for making sure things get done on time and delivered to the Commonwealth when they want them and all of that sort of thing, and to work with the writers in that development process. Matt's role is the communication with schools, with teachers, the engagement with the profession through professional associations. If you have ideas for activities, resources, you want to throw things our way and say, have you ever thought about doing this or writing this up as a lesson or something like that, please contact me. If you want to be part of a mailing list and have regular communications and you want to say, when can my school get involved, please don't contact me. That's Matt's job. So I hope the demarcation of roles is kind of clear from that. Of course, if you contact me or Matt, if you do it the wrong way around, we're going to pass the email on anyway. That's not a problem. But that's kind of our different responsibilities. We hope that you will get really engaged. We hope during the day that we're going to find lots of little activities a little bit like that we can grab and say this would just make a fantastic lesson. And I should say that the mobiles, the SolveMe mobiles, one of the first things that we're going to do is to contact the people who developed it and see if we can get the intellectual property for it and write it up into a lesson where we've actually fully developed it. So it's more than just an activity there, but it articulates the purpose, the challenge and access, and the knowledge building culture that sort of sits behind it, so that there's some stuff that teachers can access and use that go along with it rather than being just an activity. But hopefully we'll see the same thing during the day. And that's us.